now on to page 3. And this page is going to take a little longer because some of the problems get a little harder. You may need to work some of them out on scratch paper because I may use some of the entire space. So for this first one, it's got an arc cotangent, so it's just using your yellow sheet. Your derivative is you bring down the 20, and then it's going to be times the derivative of the top, 1, and then it's over the square root of 1 minus x plus 5 quantity squared, and because it's cotangent, it's negative. Now, again, this is multiple choice. It's in the standard form. You're going to be expected to conform this into negative 20. Got that? But on the bottom, they're going to 1 minus, and you're going to be expected to FOIL out this bottom. So you need to remember how to take x plus 5 times x plus 5. So that's what I'm going to be writing here. And that turns out to be x squared plus 10x plus 25 when I'm done FOILing that. And now this plus sign, or minus sign, plus negative, negative, and negative needs to be incorporated. So my final derivative turns out to be a negative 20 over a square root of negative x squared minus 10x and a minus 24 instead. So it's got a little trick to it. For the next one, now we're going into chapter 3. When I see the word absolute, I automatically think of, or I know that I have to include the endpoints. So don't forget that. So I need to first of all find my first derivative. And for my first derivative, it is 3x squared minus 16. And I'm going to set that equal to 0. And then later I'm going to set it to undefined 1 over 0. The 1 over 0 is not going to work, so that's fine. I get x squared would equal 16 over 3. So x is going to equal plus and minus when I take a square root of each side. Square root of 16 is 4 over square root of 3. Okay, so in terms of this is where I make my chart. I've got my x values. I am going to test 4 over root 3. I am going to test negative 1, and I'm going to test positive 4. Oops. I am not testing negative because remember, it's got to fall in there, and negative 4/3 is less than that. So, when I solve those, and remember you are plugging it into your original function with that, I end up with negative 24.63 for the first number. For negative 1 it came up to be 15, and for 4 it turned out to be 0. So my absolute min smallest number would be at 4 over root 3 negative 24.60. And for my absolute max, it would turn out to be, the highest point is at negative 115. Okay, so that takes care of starting chapter 3 with the absolute. Then we go on to relative extrema, and that's just finding your mins and your maxes. And for these, we're being very specific. We only want you to find the minimums. So regardless of what I need to do, I need to find my derivative first. So I come up with 10x plus 3x squared. For my derivative, set it equal to 0, and then eventually 1 over 0, which is not going to give me anything. So I factor out an x, and I'm left with 3x plus 10 equals 0, which then x equals 0, x would equal negative 10/3. So this is where I'm going to be comparing my f of x compared to f prime of x. And I am just going to test my regions, negative 10/3 and 0. So pick any point you want over here. I'm going to pick negative 10 because I definitely know it's in there. I plug it in there, negative 10. This is negative 30 and 10. This is negative times negative is positive. So here it would be increasing. If I picked negative 2, or let's do negative 1, and I plug it in, I get positive 7 and negative 1. That is negative, that is decreasing. And if I pick 5, and I plug it in 5, and this, it's going to be positive, it's increasing. And you guys saw that I was plugging it in at the factored or at the original, it doesn't matter. So the question asks for minimums, increasing to decreasing, decreasing to increasing. There is a minimum at x equals 0, and if you found the point, it would be 0, 7. I found the 7 by plugging it back into the original. So if it asks for a point, it may be in point form since it is multiple choice. Okay, so moving on to the next one. It wants us to find the extreme value in the given function. It wants us to find our minimum values between negative 1 and 3. So again, I take my derivative, 9x squared minus 4, and I'm going to set it equal to 0 and 1 over 0. The 1 over 0 is not going to do anything. And x squared is going to equal 4/9. And x is going to equal plus and minus 2/3. Okay, so plus and minus 2/3. Are they both in this interval? Yep. So when I set up my region, I'm setting up negative 2/3 and positive 2/3. And again, I'm just picking any number that I want. Now, technically, this only goes to negative 1, so you should be picking a negative number besides that, and it includes negative 1, so you can pick that. When I pick negative 1 into the derivative, because that's what I'm doing, it becomes positive. So this is positive 9 minus 4. It's going to be positive increasing. If I pick 0 and I plug that in, it's negative. This is decreasing. And if I picked 2 and I put it in here, that's positive. That would be a positive. It would be increasing. So increasing to decreasing, decreasing to increasing. There is a minimum at x equal 2/3 or at the point 2/3, 3.22. And all I did again is I plugged it into the original if it's in terms of a point to make sure that that was correct. Last one on this page. It asks us to find critical numbers. Critical numbers are my first derivative. For my first derivative, in this case though, it is a product rule, product with a chain built into it. My first term is t. My second term would be 1/2 13 plus t raised to the negative 1/2, and then times a 1, that's the derivative of the inside. So first derivative of second, add on to the second term, 13 plus t raised to the 1/2 power, and then times the derivative of the first would be 1. Okay, so trying to clean this up, my derivative, this one is going to become a fraction, and I'm going to have my t on the top, and I'm going to have a 2, and then this parenthesis on the bottom, but then it's going to be raised to the positive 1/2 power, and then it's going to be added on to 13 plus t raised to the 1/2 power. Now, I need to set this equal to 0, and then I need to set it equal to undefined. Undefined is not going to do anything. When I set this to 0, I am going to move one of these terms onto the other side. And when I do that, I get the fraction t over 2 times the parenthesis raised to the 1/2 power equals negative parenthesis 13 plus t raised to the 1/2 power. Okay, so now I'm at a point where I can cross multiply. And when I cross multiply, I get t equals -2 times 13 plus t, because the 1/2 plus the 1/2 give me a 1. So what I'm going to do is I'm going to distribute, and I get t equals -26 minus 2t. 3t would equal -26. T is going to equal -26 thirds, and that is my critical number.